Bismillahirrahmanirrahim. Assalamu alaikum dear viewers. I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's lecture is about some specific parameters of indoles, where we will study some specific factors under which the aromaticity of 5-membered ring of the indoles is lost. Secondly, we will see that which one of the two rings of indoles is attacked by the electrophile, and thirdly, we will see which position of the indoles is preferably attacked by the electrophile under normal conditions. So let's see our first question, that is, under what factors the aromaticity of 5-membered ring in the case of indoles is destroyed. So as you know that the structural formula of indoles is this one, where it consists of two rings that are fused together. The one is benzene ring and the other is a 5-membered hetero ring or heterocycle. So when we discuss that under what factors the aromaticity of 5-membered ring is destroyed, so we will study the factor where the electrophile is the attacking species. Let's suppose that electrophile is the attacking species. Then what happens of the three positions in the heterocycle? This is the benzene ring and this one is the 5-membered heterocycle. So we are talking about this heterocycle. So of the three positions that are nitrogen, alpha carbon and beta carbon, we are talking about this. Of the three positions on the heterocycle in the case of indoles, attack at nitrogen would destroy the aromaticity of 5-membered ring and produce a localized cation, and so it cannot occur. And both of the remaining positions that are alpha and beta carbons, they can be readily attacked by electrophiles, leading to carbon substituted products. But beta position is the most preferred one towards the electrophilic substitution reactions. So in this one or two sentences, all the questions are covered, but in the details we have to prove our statement that how does it happen. See, if there is an electrophilic species and the nitrogen lone pair attacks on this electrophile, and the case becomes like this. Here is the hydrogen that is already attached with the nitrogen, and here is this electrophile, and a positive charge becomes here. In this case, we may say that it is not a stabilized structure, because nitrogen, being the highly electronegative among all these atoms, cannot obtain a positive charge where it has the lowest electron density. If it may occur, then what would happen? Either it would draw the electron density from either position, from this one or from this one, and if it draws the electron density from this one, it is shifted to this position, then what would happen? That two bonds are this one, 2, 3, 4 and 5. Nitrogen would form 5 bonds, and here the aromaticity of the benzene ring would be lost. So the 5 bonds for the nitrogen are also not supported. And same case happens when this bond shifted towards this position, then again nitrogen would form the 5 bonds. If this wouldn't occur and we are considering only this bond, when this would shift to this position, then in that case also the nitrogen would form 5 bonds and that is not being supported. Because being highly electronegative atom, it would have the maximum electron density. So nitrogen should have the maximum electron density over it. Only in that case the molecule would be stabilized. So our first statement has been proved that in either case, whether it draws the electron density from either side, then it would have the 5 bonds that would not be supported, and if it forms these 4 bonds, still it would have the lowest electron density, and it normally it does not happen. So in this case we may say that the aromaticity of the 5-member ring is lost if the electrophile attacks on the nitrogen of the indole. Now let's move towards the next question. And our next question is, which one of the 2 rings is attacked by electrophiles under normal conditions? Because here one benzene ring and the other heterocycle. So among these 2 rings, we have to justify which one among these 2 rings would be attacked by this electrophile. So the chemistry of the indoles is dominated by easy electrophilic substitution of the 2 rings. The heterocycle is highly electron rich. Why it is highly electron rich? Because nitrogen, being the highly electronegative atom, retains maximum electron density and also has 1 lone pair. So in this case we may say that of the 2 rings, the heterocycle is highly electron rich by comparison with the benzene ring. So attack by electrophiles always takes place in the 5-membered ring except in special circumstances. Now let's see what happens. The benzene ring would be intact. So we will consider first attack at alpha position, then attack at beta position. So let's suppose if the attack occurs at alpha position, what would happen? This bond pair will be shifted to electrophile, as there is already 1 hydrogen present over here. This hydrogen that is already present and this electrophile, and as this bond pair has been shifted to the electrophile, then there would be a positive charge on this carbon. Now you may see that in the case of this alpha attack or electrophilic attack at alpha position, it is localized, or yes, this is localized. Because if it draws the electron density from this benzene ring, this bond is shifted to this position, then the aromaticity would be lost. So it may not be shifted to this position. This shared pi bond would not be shifted to any other position. So when the electrophilic attack occurs at beta position, what would happen? And the positive charge would be here. As you know that there is a lone pair on nitrogen, so it may be shifted towards this position, and then its resonating contributing structure would look like this. Here there would be a double bond and there would be a positive charge on nitrogen. So, and in the case of electrophilic attack at beta position, there are two resonating structures. So, in this case, we may say that the beta attack is highly preferred over the alpha attack, because in the case of beta attack, there are two resonating contributing structures. So, the positive charge is delocalized. But in the case of electrophilic attack at alpha position, the positive charge is localized, or if it becomes delocalized, then the aromaticity of the indole is being destroyed. So, how it would be destroyed? Let's see the case. Let's see. If we say that this bond is shifted to this position, or this lone pair is shifted to this position, and there would be a positive charge on nitrogen. One double bond would be here and one would be here. Then there are two bonds over here, one hydrogen, one electrophile, and there would be a positive charge on this nitrogen. In this case, the aromaticity has been lost. In this case, the aromaticity has been lost because the benzene ring does not satisfy the aromaticity rule. So, as it may not happen, so we keep it in the parenthesis like this. And this answer or this justification also covers our next question, that is, in the case of indoles, which position is preferably attacked by the electrophiles? So, first of all, the structure, the sentence structure is like this. The intermediate for alpha attack is stabilized. This intermediate is stabilized, no doubt, yes, because here the aromaticity has been retained and still it is stabilized, but this positive charge is being localized. And it is a benzylic cation, but it cannot drive assistance from the nitrogen without disrupting benzenoid structure, because when it would form the benzenoid resonance, that is this one. This is the benzenoid resonance or benzenoid resonating contributing structure. Then it would disrupt the aromaticity and it makes a limited contribution. So, the more stable intermediate from beta attack has delocalized charge. Here the charge is delocalized. So, we may say that, so the more stable intermediate from beta attack has delocalized charge adjacent to nitrogen. This is adjacent to nitrogen and is able to drive the very considerable stabilization via interaction with nitrogen lone pair, as we have seen over here. And these two intermediate structures justify the answer of this question. So, thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.